Hello, this is Robert Regine, and this is my MA104 Growth Mindset Project, the quality rep video. In this video, I'm going to explain how to do a full quality rep for a problem on page 464. So being a member of the baseball team, I decided what better problem to do than a problem that involved both calculus and baseball. This is an applied project question, and it's only part one. So the first step of a quality rep is the problem statement. The problem statement is where you write down essentially what the question is asking you, so you know throughout what you're trying to solve for. In this question, we have a part A and a part B, where part B is broken down into two subparts. Part A is asking us to show that the change in momentum over the time integral t initial to t1 is equal to the integral of f from t initial to t1. So it's pretty much asking us to show how this momentum equation from t initial to t1 equals the integral of f of t from the same bounds. Part B, if I could reference the book, the situation is a pitcher throws a 90-mile-an-hour fastball to a batter who hits a line drive directly back to the pitcher. The ball is in contact with the bat for 0.001 seconds and leaves the bat with velocity of 110 miles an hour. A baseball weighs 5 ounces, and in U.S. customary units, its mass is measured in slugs, m equals wg, where g is 32 feet per second. And it's asking us to find the change in the ball's momentum and the average force on the bat, which can be seen right here, written down in the problem statement. Moving on, assumptions. Assumptions is where you write down anything that is crucial and essential to assume in order to solve the problem without any weird or extraneous things being solved for. So, I'll read this word for word. Assume that there is no wind resistance to calculate for the ball as it travels through the air. This is reasonable because wind resistance always plays a factor, is necessary because it could change the values of the velocity of the ball when it's hit in the air. And assume that the bat doesn't break on the swing because that could change the bat's average velocity and on the swing and then change the calculation we have to do for the problem. The next step in the quality rep process is formulations. This is where you write down all the variables and all the equations you need to solve the problem, and you write down what they mean. So for this problem, we have t equals time, p equals mv, which is the momentum equation, m equals mass, and v equals velocity in that equation. F equals force, 90 miles an hour equals the initial velocity, and velocity 1 is 110 miles an hour. Slugs, like I said before, is wg, where w equals weight, g equals gravity, which is 32 feet per second. The baseball weighs 5 ounces. Time that the bat and ball are in contact is 0.001 seconds, and this is the initial equation we are given. Next step, methodology. This is where you write a narrative on exactly how to solve the problem and how you'd go about doing that. So I'll read my methodology word for word. For part A, use the substitution rule on page 413 to solve this problem and show how both equations equal each other. For B, you need to use the change momentum equation that is given and plug in the values given to solve. Also, throughout these problems, we use basic integration rules found on reference page 6. A big part of the methodology portion is writing down the exact page numbers and the name of the theory you're using to make sure everything is the way it should. And the last part of the quality rep is the results. This is obviously where you solve the problem and you show exactly all the steps and how to do that. So for part A, it's asking to show how this equation up here equals, how these two equations equal each other. So we know that F equals MA, and we know that A can also be used as m dv over dt. So given the f of t integral, we can substitute that for m dv over dt. Then we can substitute that, we can bring out the m and change the bounds to the velocity, because that's what we have inside the equation, where dv equals mv. And we know that from the formulations piece that p equals mv. So we can change that into m1 v1 minus m v naught equals p t1 minus p t initial, which back up here is the exact same thing. So that proves how both these equations equal each other. Moving on to part B and part 1 of part B. We know that the ball comes off the bat at 110 miles an hour, which is converted into 161.3 feet per second, and that the pitch is 90 miles an hour. It's negative because it's going the opposite direction where the ball is being hit, and that can be converted to 132 feet per second. We're using feet here because in the problem we were given gravity in feet, so we want to make everything nice and easy. We put everything into feet. The mass of the baseball equals slugs, which is m equals w over g. So we know that equals 5 ounces, and there's 16 ounces in a pound, so 5 divided by 16, all divided by 32. That makes it in pounds per foot, which is 0.0097 pounds. And we can use that number to plug into this equation here. Change the momentum, 0.0097 times the two speeds we have here. Plug it in, and that'll give you 2.8 slugs feet per second as a change of momentum for the ball. Moving on to part B, subpart 2. It's asking us to find the average force. So we know previously that F of t, the change of momentum, is 2.86 slugs. So the average force of the time interval 0 to 0.001, which is how long the bat and the ball in contact, is just that integral given in the beginning of the problem, just substituting t with 0.001. So if you solve this out, you end up getting 2,860 pounds as the average force for the bat. And that concludes this video. That's my quality rep. Go Army, beat Navy, and thank you very much.